Hey everyone, it's Ms. Brooks with your Daily Dose of Math. Today we're going to be discussing Section 6 of Chapter 7, which is factoring trinomials in which the leading coefficient is larger than 1. So let's take a look at problem 1, number 1. We want to factor 5x squared plus 11x plus 2. In order to factor trinomials, we have to multiply the number in front of x squared with the constant. So in this case, 5 times 2 is 10. And we want two numbers that multiply to 10 that add to the middle number 11. So two numbers that multiply to 10 that add to 11 are 10 and 1. So I'm going to rewrite my trinomial with 10 and 1 instead of 11. So this would be 5x squared plus 10x plus 1x plus 2. The moment I rewrite it, I'm going to cut it into two binomials, and I'm going to factor by GCF. So on the left, they have a 5x in common, and I'm left with x plus 2. On the right, the only thing 1x and 2 have in common is 1. They're left with x plus 2. The insides match, which remember when we factor the trinomials with a leading coefficient of 1 is what we wanted. Same thing here. This would be x plus 2. And then my other binomial would be what's on the outside, 5x. And since it's a positive 1 plus 1. So you'll notice factoring these trinomials is the exact same process as factoring the trinomials from section 5. So let's take a look at number 2. We want to factor 6x squared plus 13x plus 5. So I'm going to take the number in front of x squared and multiply it with my constant to get 30. And I need two numbers that multiply to 30 that add to 13. In this case, 10 and 3. So when I rewrite, it's 6x squared plus 10x plus 3x plus 5. We're going to cut it in half, and then factor each binomial by GCF. So on the left, they have a 2x in common, which will leave me with 3x plus 5. On the right, they don't have anything in common, so it's just factoring out a 1, which would leave me with 3x plus 5. The insides match, which is what we wanted. So we write the final answer. It's going to be 3x plus 5. And then 2x plus 1. So no different than what we were doing in the last section. So why don't you try problem 2, number 1 and 2. See if you can factor 3x squared plus 4x minus 15 and 10x squared plus 31x minus 14. So on number 1, my factors, I need two numbers that multiply to negative 45 that add to 4. So that's going to be negative 9, positive 9, and negative 5. So this would be 3x squared plus 9x minus 5x minus 15. Cut it in half. They have a 3x in common. So it's x plus 3. They have a negative 5 in common. So it's x plus 3. So my binomials would be x plus 3 and 3x minus 5. So number 1, if you factored correctly, you should have gotten x plus 3 times 3x minus 5. On number 2, this time I need numbers that multiply to negative 140, that add to 31. So that would be negative 4 and 35. So I'm going to use negative 4 and 35 to replace. So this would be 10x squared minus 4x plus 35x minus 14. Cut it in half, so I have my two binomials to factor. On the left, they have a 2x in common. That leaves 5x minus 2. On the right, they have 7 in common. That leaves 5x minus 2. 5x minus 2 match. So this would factor to 5x minus 2. And 2x plus 7. So now we're going to take a look at how to completely factor. So we can't always factor just using one method. There's actually a process we want to use. We want to first look and see if there's a GCF, a greatest common factor, that can be taken out of our problem. And then look at what's remaining inside the parentheses to see if we can factor that even more. So let's take a look at problem 3, number 1. So in this problem, 18x squared minus 33x plus 12, we want to find if there's a GCF, some term that all three of these have in common. So think about the numbers that go into 12. I see that all three of these would have a 3 in common. So we're going to start by factoring out a 3. That's going to leave us with 6x squared minus 11x plus 4. Then what I want to do is see if I can factor what's inside the parentheses. So I'm going to multiply 6 and 4 to get 24. And I want to think of any two numbers that multiply to 24 that add to negative 11. So multiply to 24, add to negative 11 would be negative 8 and negative 3. So I'm going to factor the inside with 6x squared minus 8x minus 3x plus 4. I'm going to cut it in half and factor by GCF. So I can take 2x to be left with 3x minus 4. And I can take a negative 1 to be left with 3x minus 4. The insides match like I want. So I'm going to have binomials of 3x minus 4, 2x minus 1 as my answer for what was inside. And then don't forget we took out a 3 to start, so that needs to go right out front. So sometimes you have to factor out a GCF and then break down again. So always break down until you cannot break down your polynomials anymore. So let's take a look at one more, number 2. We want to factor 8x squared minus 36x minus 20. So the first thing I'm going to do is factor out my GCF. I know that 4 can go into all of these. And that'll leave me with 2x squared minus 9x minus 5. And then I'm going to try to factor the inside. I would need two numbers that multiply to negative 10 that add to negative 9. So that would be -10 and +1. So in the parentheses, this is going to break down to 2x squared minus 10x plus x minus 5. I'm going to cut it in half and factor by GCF. So 2x and x minus 5. On the right, nothing in common, so just a 1 and x minus 5. And I see that my insides match. So this would factor to x minus 5, 2x plus 1, that's an x. And then don't forget, we originally took out a 4, so there needs to be a 4 on the outside. So this would be our final answer. So always from now on, I want you to look and make sure, is there a GCF? If there is, factor it out first, and then break down your polynomials until you cannot break them down anymore. This concludes our lesson on being able to factor trinomials with a degree greater than 1, or with a leading coefficient greater than 1. If you have any questions, please ask Miss Brooks. Otherwise, we'll catch you next time on your Daily Dose of Math with Miss Brooks.